Hi guys, welcome to this video. So in this video, let's see how to add a servo motor into our part. Like let me take an example of tire. Like let's see and let's create a working of tire. Like how we can create the part and how we can assemble it and how we are going to add servo motor into that part. So let's get started. At first, we need to select the working directory. Okay, I have selected the working directory. And then let's click on new. And I'm going to rename my part as connecting rod. And we will use template as MMNS parts for DABS. So at first I'm going to use front plane sketch, go for sketch. So this is about part modeling guys. So I'm going to create a part. So in which that we are going to assemble that part and we are going to insert servo motor for that. Here I'm going to create a circle of 50 mm dia. Click on OK. Now I'm going to extrude it as a symmetrical extrude. I'm going to add a value of 1000 here. Click on OK. And then I'm going to add some part here. So I'm going to click on this surface, go for sketch, go for sketch view. For a good view, we will use shading with edges so that we can able to see all the edges in our part. And here I'm going to draw a line. I'm going to add a dimension of 8 here. As it is a center point, we will add 4 on each side. Now let's go for dimension. Let's adjust this dimension to a value of 5 here. Let's complete the sketch by drawing a line here and here. Now I'm going to complete the sketch. So here we have to draw another circle here. So for that we can use project tool here, close it, and we can delete the unwanted segments. We click the escape button. We can see our part is completed here. Our sketch is completed here. So let's click OK and let's extrude it. I'm going to extrude this towards the side of the part. So I'm going to flip the direction. And I'm going to adjust this length to a value of 100 here. Click on OK. Now I'm going to do the same for the opposite side also. For that we can use the mirror tool, right? So I'm going to click mirror, center plane, and then click on OK. So our part is completed. Let's give some appearances for this part. And let's move on for the other parts. Going to use metallic silver color for the entire part. Then click on OK. Now I'm going to save my part. As we already selected the working directory, it will automatically go for our selected folder itself. Click on OK. Now I'm going to close this. I'm going to create a new part again and click the default template. Here I'm going to create a part of tire. So click OK and select our template MMNS parts for DABS. I'm going to do a sketch on front plane. Go for front plane sketch and go for the sketch view. So here, as we done before, I'm going to create another circle with the same diameter of 50 and the same part here, like we have done on the old part. Same dimension as 8, here 4. Let's adjust this height to a value of 5 here. Now I'm going to close this part. Now let's delete the unwanted segments here so that our sketch will be completed. As you can see the pink color. So now On that part, we have created this as a full surface, right? Full solid part, right? So here we have to create some hole for that. So for that, I am going to use some offset tool here. Go for yeah, go for chain. Select this line. Control key plus select this. Now you can see another tab is opened here. Go for next. As you can see, the full part is got selected. It is called as chain offset tool. Now click on accept, and you can see here the arrow mark is towards inside the part. So if it is outside this part, like in this right side direction towards outside, so we can add some plus or positive values to this offset. So if we had 10 here, the part will be expelled inside, it will be created inside. So we have to insert a value which is comes under negative value. So we can insert like -10. As you can see, the offset has been, now you can close this. The offset has been taken outside. Like we have entered a value of 8 here. That's our original dimension. Now we have created some offset dimension, so it will be created as 28. Like 8 means like here 10 and this side 10. So totally 28. So our offset tool has been completed. So now let's create two concentric circles. Let's give some dimensions here. As a larger circle as a value of 750 and smaller circle to a value of 540. So all these dimensions, it has been never noted by some other diamond drawings or any kind of notes. Like it has been randomly taken, like randomly chosen by me. So don't take it as a serious issue. So now our part is completed. Let's extrude it. Go for extrude. And now I'm going to use the symmetrical extrude. I'm going to provide a value of 100 here for this extrude, and then click on OK. Here for this tire, I would like to make some ribs here, so that I'm going to choose center plane, go for sketch, and go for the sketch. So here at first, like if we are going to create any sketch inside the part which we have already created, so for that we need to create reference in which part we are going to create a sketch. So at first I'm going to create a center line here, and I'm going to fix this value as 45 degree as a center of this circle. So here I'm going to place 4 points, one here, one here, and here. Now let's adjust the dimension from here till here. I'm going to make this as 33. The same on the opposite side. On the bottom, from here till here, I'm going to provide a value of 9. The same on the other side. Now let's join all these points so that it is a very easy way for creating any kind of slanted lines. So now our line tool has been created. So now we have to complete our sketch by drawing a circle. Instead of drawing circle, like we have already discussed, we can use some project tool here for this circle and for this circle. Now close it. Now we can delete the unwanted segments which has been created by the project tool. This. Now click on escape button. Now you can see our part is fully done. Now we can go for extrude. We will use symmetric extrude for this. We can adjust it to a value of 12. You can practice this with any kind of dimension, guys. I'm just taking my own dimensions. Don't worry about that. So now let's click on OK. Now one rib has been created. I'm going to create this rip for this entire circle like 1, 2, 3, 4, 5, 6, 7, and 8. So instead of taking much more time on this, we can use some pattern tool here. So select this extrude, go for pattern. That first, which pattern we are going to use. So here we will use axis pattern as it is in the circular part. We have to select the axis first. After selecting the axis, like it must be in 360 degree, right? So click on 360 and we have to yet enter the number of members. So we have counted 8, right? So we will enter the value of 8 here. As you can see, all the parts like showing this dot, like here will be our part will be generated. So click on OK. So now our part has been created. So at last we will create some round feature for this. So go for round, select this edge, control key plus select this edge. So here we need to create some full round tool here. So instead of creating, or else you can also find a midpoint value. Like we have this length of 100, right? So we can enter a value of 50. Like in the other way, if we have any kind of difficult values, like if you found out any decimal values, like if you have entered this value as 111 or 112 or 113, so we you need to calculate the mid value and you have to enter that. Instead of that, you can go for this set and then here you can see the full round option. If you click that, it will be automatically it will automatically generate the full round option here. So click on OK. So our part is created. Here you guys can add any kind of appearances for this tool. Okay, let's add some. I'm going to add the same metallic color for the entire part, except this outer face. Like I can add some rubber color for that black. This face, control key plus bottom face. Okay, now it has been completed. Now we can save our part. We selected the working directory before. It will be automatically moved to that folder. Click on OK. So our part has been completed, guys. Let's go for assembly. Go for new, select assembly here. Let's unclick the default template. Let's rename our part as motor mechanism. I think it is already open. So here I'm going to select this as MMNS ASM design ABS. On OK. Now let's switch on all the data planes here. Now, before I start my assembly, I'm going to create some axes here for inserting my connecting rod for assembling my first part. So go for axis. I'm going to use this y-axis, the base axis. Like I'm selecting this y-axis as my reference, and then I'm click OK. So you can see our axis has been created. Now let's go for assembly. I'm going to select this connecting rod part. Now for this motor mechanism, I'm going to assemble this rod by using this pin mechanism. Because like mostly they will use pin mechanism for all like these connecting motors, like force motors, servo motors, for all these things they will use pin mechanism for this. So I'm going to select this pin mechanism. For this pin mechanism, you need to select the component item axis and also the assembly item axis. So I'm going to select this axis as a component axis and I'm going to select this axis as an assembly axis. Now you can see, so the axis got coincident. If you need to change that, you can also make distance for this. You can drag this Okay, so I'm going to use coincident relation for this, and now I'm going to use some translation coincident between these planes, like part plane with the assembly plane. So I'm going to select this front plane of this part that we have created in the same front plane of this assembly. Now you can see our part has becoming yellow color. As you can see here, connection definition has been completed. So let's click OK. Now after assembling our first part, let's go for assembly of the upcoming parts like this tire. So here I am not going to use any kind of uh, like relation between those two parts, because as we have already made pin mechanism for this rod. So we can go on with that user defined tool itself. So with this arrow mark, you can also drag that part by selecting the space. You can take the part wherever you want to take it. And now, as this user defined tool is very simple, guys. We need to select this face, or you can select any kind of face. You can select this face, and we need to change this angle offset into coincident, because we need to make this face and this face join together. So we need to use coincident tool here, and then like you can drag here, and then I'm going to select this bottom surface, this surface, and this top surface. So these two need to get coincident. So here, as you can see, you can drag this part. You can see all these things got coincident, and now we have to lock this moment, right? So we need to select this face and this face and make it as a coincident. Now you can see our part is fully constrained, so you are free to go. Let's click OK. So now our part is completed. Like we will check whether this part is okay or not, whether our assembly got good or not. You can check this by dragging this point. You can see by rotating this rod, the tire will be rotating automatically. So our part is assembled correctly. So let's close this. So for the same, on the opposite side, we have to assemble tire again. It's and click all these except axis. Go for assembly. Go for the tire again. Drag it near to this part. Rotate it. Now, as the same that we have done for that part, same we have to do here. Select these two faces. Make it as a coincident. And drag down. Select this bottom surface and this top surface. Make it as a coincident. Drag little bit inside this. Like this surface and this surface. You can see it is fully constrained. So click on OK. So now our part has been assembled successfully. Let's check whether it is good or not by dragging this part. Like see, you can see by dragging this tire that secondary tire is rotating automatically. So that means this connecting rod is connected to both the tires, as it is perfectly connected. So we can close this. We can go on for the motor connection. So let's go for applications, mechanism, and servo motors. So after clicking servo motors, it is showing us to select the driven entity. So here you can see why we are seeing this kind of arrow mark here, because we have placed this connecting rod by the imaginary axis or any kind of axis like we have created before the assembly, right? So we have assembled this connecting rod with that axis by using pin mechanism. So any connection which you have made by using pin mechanism, you will be able to see this arrow. So no problem, we can click this arrow, and after clicking this arrow, you can see the entire part is becoming like you can see some orange color sketch here. So it is telling us like by setting motor here by while attaching motor here, these parts get rotated. So nothing to worry about it, guys. Let's click OK. So before that, sorry, I forgot about it. You need to add some profile details here. Like we can able to choose like angular position, angular velocity, angular acceleration, torque. Like I would like to choose angular velocity here. I'm going to take a value of coefficient as a value of 30 here, and then click on OK. So now our motor has been fixed successfully, as you can see here. Okay, so you can also rename this part to like which is suitable for you. So for me, no need for renaming it. So let's go for mechanism analysis, and here you can name your analysis definition. Like I'm going to rename this as motor analysis one. So here you have to change it as a kinematic type and click end time. Like end time is nothing but the length of the rotation. Like if you need this for 10 seconds, you can add this as 10 or 100 seconds. Like you can add that whatever you want. And the frame rate is nothing but the rotating speed. Like if you want more, like more rotation speed, you need to decrease this value. Like we can add 60 here for an example. Like you can see our part is rotating very slowly. Like yeah, you guys can see it like this tire is rotating in opposite direction, like towards right side. So no problem, we can go for this motor, go for edit, and you can flip the direction and then click on OK. Now let's go for the mechanism analysis again, go for kinematic, and I'm going to enter the value as same 60 here. Click on run. As you can see, it is moving towards forward, towards left side. So you can add this end time as 100 by reducing, like let's reduce this value to 10. Like, let's see how it works. Yes, we want to overwrite. It is asking us to whether we want to overwrite the old value, like old analysis value. Click on yes. As you can see, it is rotating faster. If you reduce the frame rate value, it will rotate fast. If you increase the value, it will be rotating very slowly. You enter the value of 60 as the same. So that's all, guys. I think you have came to know about, like, you have got some at least some idea about this motor, how the servo motor works, and how you can utilize this motor in all your assemblies or part, any kind of thing. So thanks for watching, guys. If you want more videos related mechanical engineering or any other content, you can comment below. Thanks for watching, guys. Thank you.